Now there's an apparent paradox in all this, which often confuses people. Let me explain. Let's imagine that x equals 2a. Now you might imagine there are two different ways in which you can work out the uncertainty in x. First of all, you could use the multiply by a constant law, in which case that would tell you that this uncertainty in x is 2 times the uncertainty in a. But if x equals 2a, then surely it's a plus a, because that's what 2a is, isn't it? So why not use the addition equation? If we use the addition equation, that would tell us that sigma x squared equals sigma a squared plus sigma a squared. So sigma x squared equals root sigma a squared plus sigma a squared equals root 2 sigma a squared, which is less than that. So we've got two different, very plausible ways of doing the same things, and they give different answers. So what's going on here? Well, we have to remember that the addition equation, this one, only works if the two variables are uncorrelated. Now a and a are not uncorrelated. They're about as correlated as you can get. They're the same thing! They're perfectly correlated. So that means that all this approach is wrong. You can't use the addition equation to add up two of the same thing. It only works for things that are uncorrelated. A similar situation applies for a squared versus a times a. Let's say you wanted to work out the x equals a squared. You might think that you could treat it as a times a and use the multiplication equation as well as the raising to a power equation. But once again, these two would give different answers, and this one, treating it as a times a, is wrong because, again, just like the addition equation, the multiplication equation assumes that the two things are uncorrelated, and a are not uncorrelated. So be careful. If you've got something like 2a or a squared, use the power equation or the multiplying by constant equation. Don't use the addition or multiplication ones. These only work for uncorrelated variables.